And our next question. Okay, so this one here is saying that Q is a ship at a point 10 kilometers due south of another ship, point B, that's labeled as B. R is the lighthouse on the coast such that angle P equals angle R equals 50 degrees. Now, sometimes they give you a diagram, other times you're not given a diagram. Thankfully, in this question, we are given a diagram. If you're not given a diagram, then you're just going to draw one for yourself. Mainly because we all visual learners and we need to see the information drawn in a diagram and see what the triangle looks like so that we can figure out all the unknowns. Okay, so this was our lighthouse, ship, right? 50 degrees, we can see it's an isosceles triangle, and it said due south, so going downwards, there we go, 10 kilometers, right? It says the first question, determine the distance QR. Okay, now let's look at our diagram over here. QR would be this part over here, so this can correspond with that. This side that's given to us has to correspond with angle R, which means that we need to figure out angle R first. So I'm going to first say angle R is equal to, you don't have to write out the whole calculation. 180 minus 50 is going to give me 80 degrees. Sum of angles of triangle, right? So if this here is 80 degrees and we're going to be using the sine rule, I'm going to have QR over sine 50 degrees equals, what was this? 10 over sine 80 degrees. Okay, therefore QR is equal to 10 times sine 50 over giving us 7.78. Remember, because they've given us measurements over here, we're going to include that, okay? Because this question was divided in part A and part B, for the next part of the question, if needed, I can use the rounded off version. That's because it's part A, part B. Okay, next question. Shortest distance from the lighthouse to the line joining the two ships. So our lighthouse is over here. The shortest distance from here to this part over here. Now, if you think about this, whenever you're drawing the shortest distance from one point of a triangle to the other side, it's going to give us a 90-degree angle. Okay, since I'm holding the phone with one hand, I cannot actually use a ruler, but this is what it's going to look like. There we go, right? Making this side here 5 and this side here 5. Why? Because we also have an isosceles triangle, so it's going to divide our triangle quite nicely up. Okay, poorly drawn line, but you are all with me on this, right? If I've divided it up like this and I have a right angle over here and I need to find this distance over here, let's call it h, because I mean it became the perpendicular height of the triangle, right? I can use, again, either sine as opposite over hypotenuse, cos as adjacent over hypotenuse, or tan as opposite over adjacent. That's what I can use. So let's see what I'm looking at. If this is my reference angle over here, this becomes opposite. This information that we're given over here, 5, is my adjacent. Opposite over adjacent gives me 10. So let's do exactly that. I'm going to say opposite, which happens to be h, over 5 is equal to 10, 50 degrees. And then we're just going to solve for the unknown variable. So there we go, 5.96. There we go. And we are done with this question.